Welcome, everybody. I'm Jenifer. I have a PhD in technology development and held positions both at university and in industry as a scientific researcher. In my career, first, I leveraged tech for biomedical applications, and after 10 years, my drive for gender balance and diversity brought me to found Develop Diverse, a company that uses technology to normalize diversity through inclusive communication. And today I will be talking about how to leverage AI and to avoid bias and ensure diversity in the workplace. So unfortunately, the Caucasian male has been and still is the data foundation of the majority of product testing, research, product design, and even city planning. Meaning that many elements of the modern world appear to have been designed with less consideration for half of the population, women. But the biases go beyond that. They also extend to the tech world, as I believe you know. Today, minority groups by nature are often underrepresented in data sets, which means that algorithms will reach inaccurate conclusions for those populations, and the creators will not even notice it. Let me give you an example of a biased algorithm in recruitment, for instance. You might know about algorithms that are used for ranking profiles based on their skills so that they can be matched to the open positions. In the study I'm presenting here, it was shown that applicants were ranked actually differently, not depending on their skills as they were supposed to, but depending solely on their gender. So when the name in the resume was a male name, like Adam, the profile was ranked higher for an engineering position. However, when the same resume was given a woman's name, Jane, the profile ranked higher for a designer position instead. So even though the resumes were identical, a male name was associated with engineer, while a female name was associated with designer. So the resume could be the same, but the name would change everything. Another algorithm that we use in our daily basis, in our daily lives, and thus affects our perception of society as well, is the one for object classification and visual semantic role labeling. In other words, the Google Images algorithm. Google Images uses this algorithm when we write a sentence in our Google browser to search for relevant content. In this study, for instance, they found that the models labeled the image differently depending on the gender of the person in the image. So when there was a woman on the image, it was labeled as a woman cooking. However, when there was a man, the image was labeled as a man fixing faucet. So the results were not surprising because the cooking activity is about 33% more likely to involve females than males in a training set, not necessarily in the real life. So if the training set is not curated, the trained model will further amplify the disparity. So remember to curate your training sets before training your models, unless you want to build biased models. And unfortunately, this goes beyond gender. So similar algorithms are used for facial recognition to predict who can be a suspect in a crime. They have especially biases in for races. It's well known that there are more false positives for non-white people in those type of algorithms. I could keep on going with many examples of biased algorithms, but instead, I will give you some good news. It's possible to take advantage of these biased data sets to recruit a more diverse talent pool. At Develop Diverse, we have leveraged these biased algorithms to investigate the usage of biased language in company communication, such as job ads, social media, and website content. These biased models help us create a continuously growing data set of biased and non-biased words people from applying to a job due to their diverse background, gender, age, ethnic group. And we further on build this data set into a web application to create an inclusive language translator that recruiters can use to make their text inclusive. So the software scans the text for biases, which are highlighted in a different color depending on the type of bias they represent, age, gender, ethnicity, and suggest inclusive alternatives when hovering on the color words. So how do we take advantage of bias models, bias training sets? So back in 1998, one had to design a rigorous psychological study, behavioral studies, in order to explore implicit biases. Those are the well-known implicit association test. However, recently, there has been an increasing interest in exploring the relationship between these implicit biases in people and the ones in such bias training sets, bias models. And researchers have demonstrated a striking similarity between the two. So meaning that researchers do not longer need to wear a white coat, but rather write some lines of code so that they can find the association of words that reveal these biases. So in order to investigate the usage of biased language in jobs, one of the things we did was first to collect all typical job titles and analyze if they carried any gender connotation, which actually doesn't necessarily come across explicitly, so it's not that obvious. So take a look to this set of words: programmer, coder, engineer, and developer. Do you think they are equally associated to men or women? I don't know if you have a guess, but I cannot hear you. So I will tell you, actually, they are not equally associated to men and women, as you can also see on the graph in the right. Our findings show that programmer today is equally associated with women and men. However, coder is more associated with women, and developer, as well as engineer, is more associated to men, while engineer being heavily associated. So titles could also appeal differently to women and men, given this association that we found out. Then we also use the same method to validate our data set of biased and non-biased words. And guess what? They did reflect the implicit biases present in language. First, we replicated associations that are universally accepted and that were previously published, such as the associations of flowers with pleasant adjectives, such as nice and beautiful, and the association of insects and unpleasant adjectives, such as disgusting and ugly. So we look at the effect size and at the p-values in order to define if the association was strong between flowers and the adjective being pleasant, and the strength of the association between insects and unpleasant adjectives. And the effect size, for those of you who don't know, is the number of the standard deviations that two groups differ. And if the number is above 0.8, is to be considered a large effect size. And therefore, it makes a strong association. And the p-values are defining if the result is statistically relevant. And for that, it's necessary that the number of p-value has to be smaller than 0.05. So in this experiment, we got an effect size of 1.5 and a p-value of about 0.05, both indicating a strong association of flowers with pleasant adjectives and insects with unpleasant adjectives. So we use this method to test some of the categories or all of the categories on our own data set. In this case, you can see the categories called unemotional terms and emotional terms. Unemotional referring to adjectives like logical, analytical, and emotional to intuitive and passionate. And we saw and proved a strong association using this method, a strong association of male names with our category of unemotional terms and female names with our category of emotional terms. These results show, as you can see, high effector size, and also were shown to be statistically significant. I'm showing you also the results for other type of categories that we look into, which is, the aggressive terms and the kind terms. We saw as well that aggressive terms, such as within our category, such as disrupt or talented sniper, were heavily associated with male names, while kind terms that we are within our category of kind terms, such as nice or helpful, they were heavily associated with female names, and they were not with each other's gender. as we can see from the effect size and the p-values. And the next question was, do these words associations predicted by the models actually correlate with human behavior in job ads, for instance? And if so, how much? So we got Amazon, who is today one of our customers. Yeah, amazing, huh? We got them to compare, to use our software by doing an A/B testing, meaning that they compare two identical job ads, one being the original one, carrying on the biased words that they usually use, and the other one carrying non-biased words, meaning inclusive terms that our software suggested to them. And they got 3 times more qualified applicants and closed the gender gap of qualified applicants in this round of hiring by getting 4 times more qualified women and 1.5 times more qualified men. Impressive result, yeah? So my conclusion is algorithms can be biased. So remember to curate your training sets before training your models. And if you want to discover talent beyond bias, please use Develop Diverse. Thank you. Thank you very much. And I am happy to answer any questions. I believe we have 2 minutes left until the next session starts. I think I would see a question from Christian that said, how many men are fixing the facet and how many women are fixing the facet? That's a good question, but definitely not necessarily represented by our training data sets, unfortunately. We believe, as you might believe, there are men cooking as well, pretty much similar numbers than women do. But yeah, it is not for sure 30%, 33% versus 67%, indeed. Any more questions over there? Thank you, Sandra. Nice to see you as well. Nice to see you again. Welcome to ask me any questions, send an email, connect with me on LinkedIn. It would be a pleasure to follow up the discussion or support you in anything I could with an inclusive language or bias in algorithms. Feel free. I will be here in case somebody asks questions, so you can still go on. I understand the link, the video will be recorded, so anybody can have access to the talk as well afterwards. Yeah, fantastic. Hope you're enjoying the whole conference so far. Okay, I believe I will say everybody goodbye because the next session starts. In a similar way, I just read how do we address cultural bias versus AI. I would like first to hear you. How do you define cultural bias? It would be, if culture, it can be defined by religion, can be defined by ethnicity in a very similar way than the methods I presented, because we can find data sets as well, many data sets available publicly with those bias groups as well. Yeah. Yes. But feel free to reach out to me and ask more detailed questions. I will be happy to answer any questions. So just go on. And you can like us on Facebook and on LinkedIn and so on. Develop Diverse. Okay, I will wait a bit more. I see still 17 people here. And maybe some questions can spark. Okay. Okay, I think it's time to say goodbye. Enjoy the rest of the day and take care and keep safe. Bye-bye.